Hello, everyone, and welcome to today's webinar, The Future of IoT for Energy Management. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar today is presented by InSynergy and Intel. Thanks for joining us. Before we get started, I'd like to cover a few housekeeping items. Please note the control panel on your screen. This is where you can submit questions in the question box contained in that control panel. Please send in your questions for your presenters at any time, and your speakers will address them after the presentation. Also, please note the orange arrow that is on the left side of your control panel. Clicking on that arrow will either expand or collapse the panel, so please be sure that is expanded so you can access the question box. If at any time you experience a technical difficulty, you can send us a message also via that question section, and someone will address your issue right away. So thank you. Now I'd like to introduce your speakers today, Barry McConnachie and Gustavo Reyna. Barry is the founder and CEO of InSynergy, and in this role, he leads the company in innovating economical wireless and mobile energy efficiency products that achieve energy reductions in commercial buildings and accelerates the evolution of the smart building. Barry has over 25 years of business development and engineering experience building and managing companies in software, renewable energy, data communications, and wireless technology. In 2010, Barry founded InSynergy to develop affordable energy management software solutions for the commercial building market. Previously, in 2007, recognizing the need for mitigating climate change, Barry formed Global Climate Strategies, turning his insights on developing carbon offset and CO2 reduction projects and providing software and energy efficiency, waste-to-energy, transportation, and forestry projects in the U.S. and Latin America. Your second speaker is Gustavo Reyna, Business Development Manager with Intel Software and Services Group. Gustavo manages the Intel business development and go-to-market strategy and programs with Intel IoT software solution partners. He works in several vertical market segments to assure that industry requirements and business needs are addressed in delivering solutions. He's been working with facility managers, building management companies, building automation groups, and designers to fully understand the challenges and opportunities in this industry. Gustavo has extensive experience in IoT services, global marketing, and product management. He holds a master's in management of information systems from the University of Denver and a bachelor's in communications from the University of Maryland. So before I hand it over to Barry, who will speak first, we have a poll question that will appear on your screen there. And we'd like to ask you to please give your input here. Has your organization adopted an IoT solution to date? Just please let us yes or no. It'll give us a good framework for the presentation. If you just take a moment there, the results will be shown momentarily. Okay, so let's see on the screen. We have yes, 24% of our audience has adopted an IoT, no, 76%. So thank you very much for sharing that. And with that, I'm going to hand it over to Barry McConnachie. Hi, Barry.
Hi, thank you, Ann. Appreciate the opportunity to speak today on this webinar. The topic we're going to cover today is the future of IoT and specifically for energy management. As Ann had mentioned, InSynergy is a partner with Intel in the IoT Solutions Alliance, and we will be discussing a little bit more in detail of how that architecture looks as we progress into the webinar. A little bit of overview first. What we've done with the InSynergy IoT platform is we've leveraged advances in cloud-based computing, advances in mobile technology, and advances in wireless devices to be able to provide a solution for energy management in a variety of sectors, places like retail establishments, food establishments, education, offices, healthcare, and industrial. And by doing this, we can bring a variety of devices and a platform for reducing energy consumption in these buildings. Typical energy consumption reduction can be in the 20 to 30% range. And what we're going to discuss on this particular webinar is all about the need for measurement, the need for measuring your energy consumption. And the reason is you can't reduce your energy consumption until you know what it is, until you measure it and know where and when you're using your energy. A next generation energy management system using IoT consists of a cloud-based platform communicating to a series of devices in the locations. So in each location, we're going to have a series of devices that are wirelessly connected, and communication occurs between those premises and the cloud. And the cloud is managed by a series of applications, from web pages to mobile applications. And this allows us to have unprecedented visibility from anywhere, control of your locations from any location that you choose, and very simple and cost-effective way to reduce your energy spend. Some of the hardware involved is the Intel Internet of Things gateway platforms, as well as things like smart thermostats, meters, sensors, lighting controls, and all of these are wirelessly connected so that you have a integrated platform that can access any device on any location from anywhere.
Thank you, Barry. I think we have a second poll question to present now. And there we go. We'd like to ask you to answer the second poll question. If your organization does not have an IoT solution in place, what is the biggest barrier to adopting this type of system for you? Is it cost, complexity, or security concerns? Please just select one, and we will again share the results with you on the screen.
Thank you.
So let's see if it's cost, complexity, or security concerns with our audience. Oh, pretty much even. Complexity, 36%, security concerns, 33%, and cost, 31%. So thanks again for sharing that. And I'll hand it back to the speakers.
Okay, I'm going to briefly describe the architecture, and then we're going to deep dive down into the security aspects. So as I mentioned, we have a cloud-based management platform where the energy management dashboards in your web pages, mobile applications communicate through the cloud into each location via the Intel IoT gateway. At each premises, you will have a series of wireless devices, and they're highly secured with the protocols and other aspects that we've implemented. Everything from Zigbee Trust Center and encryption will prevent any unauthorized access in the wireless domain to the internet gateway. And at this point, I'm going to turn it over to Gustavo with Intel, and he's going to describe more about the Intel gateway and more about how security is implemented to ensure that your data and controls are absolutely secure.
Thank you very much, Barry. And we can move to the next slide here. Okay. My name is Gustavo Reina with Intel. And Intel and the IoT Solutions Alliance work with facility executive, as we're doing in this webinar. We work with smart building managers, facilities associations, designers, and developers, because we really want to understand the requirements and the challenges to create tangible benefits of implementing a smart building solution. The concerns that are most prevalent in our discussions with facility managers are security, scalability, and interoperability. I would expect that these are important aspects of the solution to you as well. Ensuring the integrity of your data network, ensuring that the solution is cost efficient, but also able to scale as you need it, ensuring that all the components from the sensors to legacy equipment are all interoperable via open program interfaces that comply with industry standards. These are crucial factors to the return on your investment. And this is where we play in creating an IoT gateway architecture that resolves all of those concerns. So within the InSynergy solution, the Intel gateways enable the orchestration of the various devices and the management, excuse me, and the management of the devices in a smart building deployment. So the gateways provide the support for a wide array of device interfaces. As you can imagine, there are a number of systems and legacy systems in a deployment. So the need is there to support a pretty large amount of interfaces and protocols. And also, most important than anything is when you add sensors or other devices into your network, to assure that they are secure. And so the advantages of the Intel Gateway Security deployed in a smart building begin with this ability, the ability to establish a chain of trust, right? To attest that there is trustworthiness in the devices from the time the chipsets and sensors are manufactured all the way to when they are deployed in your facility. And so that you can assure your IT people, your all of the systems in your facility that there is integrity in your network, that nobody can add a device without your knowledge, that a device cannot begin to communicate with others without your knowledge. And so this is what gives you the confidence that the sensors that measure and transmit the data, the gateways that orchestrate and connect all that data to the cloud, all of those components are secure, and definitely gives you the ability to manage and provision those devices remotely, right? It would be highly inefficient if you had to physically go and change or update software in all of those components. So the ability to manage and provision those remotely, it's a pretty important efficiency factor for you. What we provide is called a device attestation. So it essentially ensures that the gateways are trustworthy and prevents sensors or other devices to be added to the network. In addition to that, enhanced privacy ID encryption has been in most Intel chipsets since about 2010. And so that ensures that your hardware, there's a hardware level lockdown from the very edge of your networks, from the sensors all the way to the cloud. This is really what gives you the confidence to deploy the solution in your facility. I think that addresses a pretty important factor. Barry, if we can move to the next slide. I would also say that an important factor, and I think, let me perhaps come back one slide, or, okay, I'll speak to that on this slide, which is fine. Obviously, the gateways need to have the flexibility to implement that security that I mentioned, to be scalable and to provide interoperability. So Intel, as you know, provides a lot of the chipsets that enable manufacturers to create a number of IoT gateway versions, I guess, different levels of protocols, different levels of connectivity, different price points. And so we work with this large group of manufacturers who deployed something, manufacture something that is really most appropriate for your specific need. And so, for example, you may have very specific needs in terms of the connectivity protocols that you need to support, the ability to scale from very basic functionality, perhaps if you have a small deployment or a small array of components in your network, to perhaps more complex deployments and data processing needs and perhaps analytics that you need to provide. So in order to provide that flexibility and functionality, and as well as different price points to make the solution appropriate for your specific need, we work with a number of manufacturers of gateways that go from the very basic chipsets that really provide very basic functionality, right? Translating the proprietary protocols into more of open programming interfaces or APIs, or aggregating the data from the sensors to stream it to the cloud. And there's a level of gateway supporting Quark chipsets for that. There may be a more medium level performance gateway that needs data insights and controls within your facility, and they use a more advanced and more higher performance atom-based chipset, all the way to Core i7 chipsets. And that really goes into if you need to add additional applications into a gateway or provide very complex analytics at the edge. My point there is that these arrays give you the flexibility to implement the Insenergy's energy management solution really in a variety of environments, in a variety of interoperable levels of or sets of components, that is not a single monolithic solution that is only applicable, across the board for everyone in a single way of deploying. There's a lot of open protocol and the ability to integrate through APIs other applications and other user interfaces into it. So I think that's really, for the most part, the benefit of the IoT Gateway. And I'll give it back to you, Barry.
Okay, well, thank you, Gustavo. That was a great description, and I sure appreciate your insights and description of how we can make this platform super secure, and you can feel comfortable with your important data and control capability. Another thing that I wanted to point out, as we mentioned about the different kinds of Intel gateways that we have available, as your needs grow, we can continue to evolve and upgrade and seamlessly bring a solution to any size of building. As we add in things like HVAC control, lighting control, and what we're going to discuss today about metering, together with sensors and other kinds of software that's built into the platform, this allows you ease of use from any location. One of the things that I want to also describe is, as things change, as new features are found and invented, as better security is developed, these gateways are upgradable. So the software from the cloud goes into the gateway, and in some cases over the air into devices to upgrade and continually stay at the very most current cutting edge technology available. So we're going to talk a little bit more today about energy usage, specifically measuring your electricity. Big question you may have is, why should I meter electric usage? I get a utility bill. Isn't that sufficient? Well, some of the things that we can bring you, and any bona fide energy management solution will have energy metering built in. We want to have the ability to measure not only what energy is being used, but when it's being used, how much energy at any particular time. We want to be able to examine these patterns. We want to be able to see, is there energy being consumed outside of the normal operating hours that my business is open? Is there an anomaly where peak power is being reached in certain times of the day and we can reduce the peaks? We want to examine a little bit more about the quality of the power and see, is there a way that we can improve that quality and save money? So this metering capability gives you that kind of visibility and allows you to reduce your consumption and reduce your cost. Some of the ways that we're going to reduce cost is simply by making sure that energy is used when needed and energy is not used when not needed. You have two main areas in most buildings that are responsible for most of the energy used. HVAC systems in most typical buildings, particularly in the South, is responsible for over 50% of the energy consumption in the building. Lighting is responsible for another 25% of it. So between HVAC and lighting, if you can control those two areas, you can impact 75% of the energy used in most buildings. We're going to show you a little bit about how you would use scheduling, and this is an application here where we have set the temperature at certain times of the day, and we've allowed the temperature to go much higher or much lower during the off-peak periods, off-occupied periods, so that we can reduce energy consumption. We can show you a little bit about how your mobile application can immediately identify if you've got energy use outside of those peak periods and you need to address that. So one of the ways that a modern energy management system connected with Internet of Things devices allows you real-time access into your devices allows you to see when you have a problem and immediately take action. So we're going to be able to use this application to zero in on problem areas, as well as receiving notifications right there on your handheld if you have an area where there's a problem and you need to address it immediately. I'm going to show you one case study here of how we were able to use schedule optimization to save a client over 21% of their overall energy consumption. At this point in the graph, this is where we implemented the system. So prior to implementing the system, what we're looking at here is 15-minute interval data stacked throughout the day of every day of the year. And then we will color code this energy consumption from either high use, medium use, or low use during that 15-minute period. So this heat map can very visually show you where your energy is being used, or at least what time of day it's being used and when throughout the year. What we're looking at in these periods marked with an A is high areas of energy consumption prior to when the building is open. The building in this particular case is open at 6 a.m. and closed at 6 p.m. Prior to implementing our system, we were getting a lot of energy consumption before 6 a.m. and after 6 p.m., which is driving up energy costs. After we've implemented the system, we can see a very nice defined cutoff before and after the building is open, so that those periods of energy consumption are not present and are largely responsible for the energy reduction. Some other ways that we reduce energy is when buildings are closed for the holidays. There might be 10 or so holidays per year. Simply by reducing the energy consumption during those days, we will actually save a great deal of energy there as well. So together, just using efficient scheduling, we were able to reduce the energy consumption very substantially. Next case I want to show you is with another client of ours, where they have a number of locations, and we have used energy metering across all of those locations so that we're able to break down the usage into areas of the buildings. And by doing this, we're able to quickly identify where are the energy spikes, where are the energy peaks occurring. And so we can take a series of buildings or a series of meters together, and these are sub-meters, and we'll just highlight those meters and be able to see what the consumption is. And it becomes very apparent that there are certain times of the day when peaks, energy peaks, are being reached. These are 15-minute intervals throughout the day, and we can see certain periods of the day, mostly in the afternoon, when we peak the energy consumption. And as most of you know, utilities charge extra for peak demand. And so you will receive demand charges on your bill, sometimes referred to as delivery charges, sometimes referred to as other things other than peak demand. But what it really represents is 15-minute periods throughout any day when energy is peaked. And if we can reduce these peaks, we can save a lot of money on the utility bill. One way that we do that is we will go through all the meters and see where the peaks are occurring for a group, and then we can go one by one through each of the meters and find which one is actually causing that peak, and is it possible to reduce that peak. Some ways that we can reduce the peak are cycling back equipment if it can be reduced a little bit. Sometimes we can take the HVAC systems and stagger their usage so that one will fire, then the other will fire, then the other will fire. By doing these things, we can level off these peaks and cause a reduction in your utility bill. I'm going to talk a little bit on this slide of another case study we've done with one of our clients, where we were able to measure their power factor and save them a great deal of money on their utility bill due to power factor. What is power factor? Well, power factor is really the ratio of real power to apparent power. And normally those two numbers can be very close together. Real power almost equal to apparent power, and that would yield a power factor close to 100%. But in the real world, that's not always the case. And oftentimes, depending on the type of load, like an inductive load, and inductive loads are things like motors, anything that has electromagnets in it where the coil is consuming the power, that will cause the real power to be less in relation to the apparent power, which will give you a lower power factor. And in cases where we have a lower power factor, such as this example on the top here, I'm looking at the line where the power factor is less than 70%. Many utilities will assess charges at about 85% power factor. So if your power factor falls below about 85%, you will receive surcharges on your bill. These surcharges can be very substantial. It's a fairly simple matter once you've identified where you've got power factor problems to correct them. Things like adding passive capacitance or other power factor correction equipment can be very, very cost effective in relation to the amount of savings you will get on your energy bill. So by using metering effectively and submetering in sections, you are able to identify those areas where power factor is a problem, and you are able to correct them. In this case, we're able to see the power factor has risen to over 90% and eliminated the power factor surcharges for these zones. You can also, after you've corrected the power factor, or prior to that, you can adjust alarms and put an alarm on a particular submeter and have it alert you as soon as power factor becomes a problem, so that you're aware of the problem before you get the bill and you can do a correction. This area we're going to talk about in this slide really has to do with submetering and using submetering to adjust the billing for your tenants. If you have a large multi-tenant facility, each tenant may be receiving a bill based on their square footage. They may not necessarily have a utility meter installed on every tenant's space in those buildings. In fact, that's usually the case. Tenants don't like this because oftentimes they may be getting billed based on their square footage, but there are other tenants in the building that use a higher energy intensity per square foot, and these tenants that are using the higher energy are causing all the tenants to have an increased bill if it's based on their square footage. So by submetering, you provide your tenants with an accurate bill of only their energy consumption, and they're not being billed for other tenants' usage. This improves tenant satisfaction, improves rental rates, and even improves the overall value of the building. Some ways that we also appreciate submetering is that in a submetered situation, each tenant, because they're responsible for their own bill, they're more likely to want to implement energy savings measures that can reduce their bill. Whereas if they were only being charged by a square footage, they're less likely to want to implement the cost of energy efficiency because they're not going to receive the direct benefit on their own account. I have one other example with a case study that we did for one of our clients, and one of the best applications of efficient metering is validation of energy savings measures. So in this case, what we have is a food services company that implemented LED lighting. And as you can see down this particular display aisle, the before picture has a standard fluorescent tube, and these are consuming quite a bit of power and producing a fairly small-ish amount of light. And you can see on the after picture, when we've implemented LED panels, the lighting was dramatically improved in the area and the power was reduced. In order to determine exactly how much the power was reduced, we used EMS metering, and we metered this whole zone. So we were able to see the before picture and the energy consumption, and the after picture and the energy consumption. And we can immediately show that there's a dramatic savings implemented by putting this system in, and we're able to very quickly calculate the return on investment for implementing these efficiency measures. So at this point, I think we have a final poll question, and then we're going to turn it over for a Q&A.
Thanks, Barry. Yes, that's correct. Yes, and please continue to send your questions in, but first, please answer this poll question. And it's, if your organization doesn't have an IoT solution and you're considering adopting one, what would your timeline be? Is it 1 to 3 months? Are you on the cusp? 4 to 6 months, also on the cusp? Considering it 6 to 12 months, or 1 year and out? If you can kind of share what your timeline might be for adopting an IoT solution, we will show the results shortly. Thank you. And then we will go into the Q&A. Okay, so the results will pop up momentarily. There they are. 1 year plus, that's 71%, and down the line, 6 to 12 months with 19%, 4 to 6 months, 10%. So looks like everyone's thinking about it, but it's a ways out for about almost 3/4. Thank you very much. Okay, so we can jump into the Q&A. Thanks again, Barry and Gustavo. We have a couple good questions here for you that we can pose and hopefully elaborate a bit more on your presentation. So yes, if you can talk about, first of all, if you could maybe elaborate a bit on the partnership between InSenergy and Intel, that might be helpful to kind of set the base for the Q&A. Could one of you share what that partnership entails?
Sure. Oh, absolutely, absolutely. And as you know, Intel really has more than anything a reference architecture, meaning that we have looked at all the components that will comprise an IoT solution from end to end. And it is complex, and really it takes more than just one particular type of vendor or a particular type of equipment to make it happen. And so what Intel did, given that really more than anything we're concerned that all of the software solutions run in secure environments, in high performance environments, is create this IoT Solutions Alliance, which is really a conglomerate, an industry conglomerate of gateway manufacturers, device manufacturers, a lot of the really great software solutions that you see here with InSenergy. So it's really more than anything a collaborative group. We make sure that we follow standards, that things are interoperable, that we have different price points for different types of solutions, etc. And that's what the Intel IoT Solutions Alliance is all about.
Thank you.
Thank you, Gustavo. I want to chime in on that just a little bit more too, to describe that InSenergy is very proud to be part of this IoT Solutions Alliance. It gives us access to a whole ecosystem of other IoT kinds of devices that may be out there, as well as in the future the devices that will be coming along. So I just wanted to say that we've gone through extensive testing together with Intel to show that our solution together has the performance required and the reliability that we desire. Thank you.
Thank you. Thanks for the elaboration. So, okay, we'll dive into some questions about the actual system and the InSenergy system. So, Barry, you gave some good case studies there, and we have a question of a more general nature, asking what does the implementation, generally speaking, look like with the InSenergy system into a facility, in terms of if there's already obviously some devices in place, some building automation systems, what might that integration look like if they're looking to bring in a solution such as yours?
Thank you. Yeah, that's a great question. We get asked that a lot, and I think that's probably one of the biggest advantages to the Internet of Things platform. One being accessibility, but the ease of implementation is of primary importance. By making wireless devices communicate, it makes those devices easier to implement. We don't have to run control wiring, and we don't have to run communication wiring to everything. Each device can communicate wirelessly, and in some cases through its neighboring devices, into the gateway. And so this way we can rapidly install new devices simply by placing them where they belong, and they will communicate through the gateway and automatically be activated. So those devices are pre-provisioned, they ship down, and you essentially put power to them, and they begin communicating and become active in your platform. We can you
I'm sorry, Barry. Go ahead.
Oh, okay. I was going to talk a little bit about the specific types of devices. Everything from like an HVAC thermostat, which would be a fairly simple install by an HVAC technician, low voltage, put five or seven wires on, replacing the old thermostat, put the new thermostat, and it will begin communicating. Energy metering, oftentimes the energy meter will be placed close to the circuit panel where the energy where the breakers are, and we would put what's called a CT, a current transducer collar, and these are open collar snap-on around the wire, and at that point now the meter is communicating wirelessly back to the platform and bringing the meter data in. In some cases, such as sensors, they can be completely wireless as well as battery powered, and you can essentially place a sensor where you want that sensor, and as soon as you turn it on, it begins sending its data back into the gateway and back up to the cloud.
Thank you. So based on that, to zoom in a little bit more, you had shown a number of case studies there. So we did get a question, can you talk about one of those or another that's an active customer that uses InSenergy with Intel, an active customer you have, and maybe kind of what results they're seeing, whether it's someone that you showed on the screen or otherwise.
Yes, and I showed you a number of examples, and we see a wide variety of sectors, everything from industrial to office spaces to food preparation, and the normal and typical energy reduction that we oftentimes quote is 20%. So in many cases, we're going to see in excess of 20% reduction. Such as that building in Stream Realty building in Dallas was over 20%. Our facilities that we've done at GE have achieved over 20% reduction, all the way up to that last one I mentioned, LSG Sky Chefs. We implemented LED lighting and achieved over a 60% reduction in energy associated with lighting.
Thank you. And what is the return on investment timeline? I imagine that varies by project and and facility type and operation. But what do you say to facilities people that are asking about return on investment for this type of system?
Well, sure, and that becomes a very important component of the IoT platform, is that we have been able to achieve a very nice cost reduction by reducing the number of components, reducing the complexity, reducing the install cost, and reducing the cost of the components themselves. So by doing all these things together, we're seeing ROI payback periods inside 2 years in almost all cases. And one of the other ways that we're able to do is by enabling the system as a service, where you are making a payment on a monthly basis. That monthly payment is less than the energy reduction that you achieve. So the payback period on that system is instantaneous. You put the system in, you pay monthly, and you pay less than your energy costs that you would have less than the cost of the energy that you've reduced. So in other words, you're going to save more than you pay every single month. So the payback period is immediate.
And we did have a question come in related to cost. What is the average cost per point? Can you speak on that? And also, is the equipment proprietary, as a separate question?
Okay. So the average cost per point is a little difficult to calculate, because you've got different kinds of points. If you have a thermostat, it may be in the range of a few $100s spread out over a period of 5 years. Or if you had a sensor, is much, much less, or a lighting controller, much less cost. So it depends on this very specific device that you're going to place. And then what was the second question about this? Proprietary?
Yes.
So basically, what we're using is off-the-shelf hardware connected into a software platform. So all of the software would be considered proprietary. We use standards-based interfaces such as BACnet, Modbus. We use standards-based protocols such as Zigbee. But the technology that ties it all together and performs analytics and performs controls would be proprietary all the way down to the firmware. The devices themselves, though, are off-the-shelf hardware produced by a variety of manufacturers, big names that I know you've heard of, and so those specific devices are available on the open market.
Thank you. Okay, so then let's see. We have a question in terms of the compatibility. Does the InSynergy solution work for both Android and iOS, Mac, and Windows? Is it compatible with all those types of systems or operating systems?
Yes, absolutely. iOS, any variety, iPads and iPhones, Android, absolutely. Mac, Windows, of course. We do not support BlackBerry, and there's maybe some other, devices that are in very limited distribution that we don't support, but we support all the big ones.
Okay, great, thank you. And we have about, let's see here, at this point, one last question. You showed a number of, a variety of facility types here, and just wondering if you can talk about what kinds of facilities beyond what you showed that you're in. Are you in education campuses, healthcare? I mean, are there good applications there as well in terms of a good fit for the InSynergy system?
Absolutely. Fits great in education, in healthcare, fits great in retail and restaurants, office spaces, commercial settings such as industrial buildings. And sometimes these are mixed use. So we oftentimes will see a campus that may have warehouses, it may have industrial manufacturing, all the way to cafeterias and office spaces. So we support a wide variety of sectors.
Wonderful, thank you. Okay, well, that is all the questions we have. I want to thank you, Barry and Gustavo, for the presentation today.
Well, thank you so much. Thank you, Gustavo. Thank you, Anne. Appreciate it very much.
Wonderful. Wonderful. And thanks, of course, to our audience for attending today and for sending in your questions and for your attention. A recording of the webinar will be available online at facilityexecutive.com, as well as through InSynergy and Intel. So thank you very much. Have a great afternoon, and you'll see some links up on the slide there. You will be able to have access to those through the recording, and also we'll follow up with an email. So thank you very much, and have a great afternoon.